Welcome, grade 7 and 8. Well, let's take a look at lenses. And let's see if we can figure out how light reacts to traveling through different types of curved surfaces or lenses. Well, we've already taken a look at two different types of curved mirrors. We've taken a look at a concave mirror and a convex mirror. Well, now we're going to take a look at concave and convex lenses, and we see how light not bounces off the object, but how it's affected as it travels through that particular object. Well, knowing how light rays bend when going from air into a more dense medium can actually help us understand how lenses affect light rays. A lens is a curved piece of transparent material, like glass or plastic, something that we can see through. We're actually going to be getting into this a little bit later on, but our eyeglasses are an example of a lens. And we're going to talk a little bit later also about what's the difference between nearsighted and farsighted, and how do these lenses actually impact or affect or help the way that we see, and why are people nearsighted and farsighted. But we're going to get to that a little later. Light refracts or changes direction as it passes through a lens, causing those light rays to bend, either bend in or bend out. A double concave lens. That's going to be our first one. Here we see two images, a double concave lens and a double convex lens. Remember that concave means that it comes in, it caves in. And convex means that it bubbles out. And here we just have a double one, meaning that we have one on either side. So a double concave lens is one that is thinner and flatter in the middle and kind of goes outward around the edges. So it caves into the center and it's thicker on the top and on the bottom here. Light passing through the thicker, more curved areas of the lens will bend more than light passing through flatter areas instead. So here we see the red ray. As it passes through, it's actually going to reflect up, while the blue ray reflects down. And the yellow ray in the middle, it's just hitting kind of a regular flat surface. It's not going to bend because it's already coming in straight. And so it's going to continue straight in that same direction. It's hitting it at a fairly flat spot as well. And so here we see that it causes the light rays to bend out in a double concave lens, which is the exact opposite as what we saw it do with the concave mirror, where it came in. I mean, eventually it did go out, but after it flipped. Instead. This causes rays of light to spread out, and we use a fancy word for that when we're talking about light, when we're talking about rays, and we say that that's diverge. So these light rays are diverging or spreading out or separating more and more after they pass through that type of lens. A double convex lens, on the other hand, is one that is thicker in the middle than around the edges. This causes the refracted light rays to do the opposite. Instead of diverging, they're coming together, or what we call converging, onto a particular point. We're going to talk about that. We're going to call that the focal point a little bit later on. So how do we start to understand this? How do we start to understand then different effects on some of these lenses? Well, lenses are probably the most useful and important of all optical devices. Just think about where our world would be for some of you without eyeglasses or without contacts. Eyeglasses are made from lenses from all the way back as early as the 13th century. Imagine those of you who needed glasses, though, if you lived before the 13th century. You just have to get by the rest of your life without being able to see as much, or everything being fuzzy or blurry. An image forms when light rays from an object converge or come together. The light rays spread out from a point on the object. A convex lens refracts these rays so that they can actually come back together. So here we see different types of a small curve versus a large curve, and how that impacts how close or how far those light rays eventually converge to. This is, by the way, and again, I'm jumping ahead a lot here, but this is the key between different types of glasses prescription. How thick or how thin they need to be all depends on at what specific point do they need to converge in order to allow you to see things more clearly. And the light rays spread out from a point on an object, and the convex lens refracts those so that they come back together. However, the lens directs light from the left portion of the object to the right portion of the image. Similarly, light from the top of the object, as we see here, light from the top of the object is directed to the bottom of the image here. So we kind of get a flipped view of what's going on in this flower. Thus, an image formed by a double convex lens is occasionally inverted or flipped upside down rather than upright. Both projectors, so different types of projectors, if you think way back when, maybe you've seen one kicking around, the old school overhead projectors, but also a lot of film projectors as well. They use double convex lenses in order to create images. But since we see the upright image on the screen, the image in the film actually needs to be placed upside down so that when it's flipped, it's actually the right way around for us seeing it. It gets a little bit more complex, but it's kind of neat the way that all these things kind of play together in order for us to be able to see an image properly. Well, that was just kind of a bit of an introduction to some of the different types of lenses. In our next video, next week, we're going to start diving into our eye. And we're going to start seeing how is it that our eye, because our eyes also have built-in lenses, how is it that it uses this refraction in order to let us see? And what does it mean if you're nearsighted or farsighted, and how does that affect the way that we refract things? And how does our glasses help with that? And how is it that cameras can imitate a little bit of what our eyes do as well? And so that's just kind of a little sneak preview as to where we're heading in our understanding of not only how light works, but how light travels through different types of lenses in order for us to better understand optics, the way that we see, and the way that we can interpret the world through the lens of our eyes and the lens of a camera. All right, well, that's it for today, grade 7 and 8. I hope you have a great rest of your day.